So this is section 2.5 notes. We're going to be talking about the additive inverse. And essentially what this is doing is we are going to be talking about getting, speaking of talking, stop. If you have a question, I'd be happy to answer for you. Do you have a question? Okay. We're going to talk about how it's much easier to visualize adding and subtracting integers or dealing with integers when we are just getting it to be addition. So this is another time that we're going to be using one of these mats. So 50, that's fine. So we have 12 plus negative 7. And I'm going to go just how we did the other day, where my circles are going to be positive integers. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12. You all right? You need to get a drink. Go ahead. There's lots of people having hiccups today.
I'm allergic to hiccups. Don't give them to me, I'll die.
Plus 1, 2, 3, 4, 5, 6, 7 negative integers. And from what we've been learning the last couple of days of class, when you see this next to this, a positive integer and a negative integer, what do those become? Yes? A 0. They zero each other out. Okay? So we have equals. We're going to have the positive 12 integers and the negative 7 integers balance each other out. I'm going to use red. Those zero each other out. 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 What is left? Yes? 5 positive integers. Beautiful. Maybe we're going to put them right down here. 1, 2, 3, 4, 5. Okay? So that's when we're adding. Let's talk about subtracting now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Draw. Minus. One, 2, 3, 4, 5, 6, 7. Now, the one on the left, we have negative integers zeroing out positive integers. The one on the right, we just have a whole bunch of positive integers. That isn't as easy to visualize. But if we needed to, we could do this whole circle thing again. But we have all these positive integers on this right example. And we would think of it as being just 12 minus 7 looking at here, rather than having a deeper understanding, a deeper visualization, a manipulative to adjust these positive and negative integers. Because there aren't any negative integers in here, right? Are there any negative integers on the right side? No? No. So we're just going to go 1, 2, 3, 4, 5. These ones aren't, you can't play with these ones on the right side. Right? These on the left side here, we have our stuff that's canceling each other out. We can see what's happening here. But on this side, we just have positive integer, positive integer, positive integer. All these guys are still positive integers. It's just being subtracted in the middle here. If you had to choose which one of these two is more visually, let's see if I can erase these. From looking at these two, which one do you think is a little bit clearer from just looking? And be honest. Abby? 12 minus 7, you like that one better? Okay, how about from looking in the mats, the subtraction mat and the addition mat? The question, I mean, anybody, I'd hope any 7th grader in this class would be able to answer this one here, 12 minus 7. How about when you're looking at the way it's displayed within the mats? Which way do you like better, Jacob?
Like the map there with the dots.
Yes, you have two choices. You have choice 1 or choice 2. Which one do you like looking at more, Jake?
Choice 2?
Do you like choice 2 better?
Yeah.
Okay. So that's 2 for 2. Lena? You like choice 1? 1? Okay. Wait, 1? 1? Okay. So we do have a couple 2s, and that's fine. We do have a couple 2s, and that's fine. Good. Choice 1 here, using your see, I almost did it again, integer parts that you cut out. This is representing, and this is called something, the additive inverse. Okay, the additive inverse. So you can see everything that we want. Everything is going to be A plus B, and that's what we're going to be doing today. Speaking of doing things today, what I would like you to do, you are going to look in your book on page 89, and you are going to write the definitions of these two things here. Well, yeah, you're going to answer these first two, and then you're going to look at the rules for subtracting integers. Rules for subtracting integers are going to be found on page 89 somewhere, and it's going to be something that's popped out. And there's room for examples, and that's why it's there. If you're not done with that front side, you need to finish that sometime other, but we need to move along, so I want to give you all a couple of minutes to work on your homework, hopefully. So we have something that you need to write on the top of the back. It says additive inverse, making everything A plus B. Additive inverse, making everything A plus B. And you should have written what the additive inverse is on the bottom of the front side of that page. And we're going to be practicing with that now. So, in order to make everything A plus B, this is going to be our A. Oh, well, okay. This is going to be our B, but we have to make it A plus B. And as that rules for subtracting went, we need to change the sign of B if we are changing the sign of the subtraction. So what that means is we are taking this negative 5 and making it into, we're going to negative 5. Now this is plus, and by the additive inverse rule, we are going to keep this at a negative 11. So we change the sign, but we keep that negative there, because on the number line, that negative integer still has to hold 11 spots. So we're changing the sign from negative 5 minus 11 to make it a plus a negative 11. Yes, sir? Because all but 3 of you liked numbered 1 on here. Okay, so all but 2 of you liked number 1. Okay? So here we did the additive inverse. This is without doing that. Okay? Does that help? Yeah, you get the same answer, but now we can visualize with the integers, positive and negative. So without needing to use our integer blocks or whatever, what is negative 5 plus negative 11? Okay, well, first off, let's look at this from a distance. Freddie, can you tell me if this is going to have a positive or a negative value? Negative, because we have a negative plus a negative. It's always going to be negative. Okay? Jace. Good? Okay. Harrison, what do you think? Negative 16, you are correct. I agree with you. also there's this one that I made a fool of myself last period doing a dance. Okay? When you have a negative and a negative, you have a positive. Okay? Yes. All I'm saying is, yes, if that was recorded, that probably would make best dance video for next year's VMAs. Just saying. So, yeah. Yeah. Exactly. Yep, because you're still keeping the same value. Okay? Okay? You're still keeping the same value. That's something that someone didn't notice till later. Good. So, which one of these two, or is this sum going to be positive or negative? Raise your hand. Give me thumbs up if you think it's positive, thumbs down if you think it's going to be negative. We're still on this one. Number 2. Okay? I agree with you. I don't think anybody said positive, which is good. Now, with this, it's because the absolute value of this is bigger than the absolute value of the other thing. Okay? So we have negative 4. Negative 4. Negative 4. For this next one, I'm going to rewrite this a little bit because of the homework, something you have in the homework. We're just going to rewrite this as 5x minus 12x. We're going to rewrite this one as 9qr minus negative 3qr. So rewrite those. So if I were to rewrite number 3 to have the additive inverse, can someone please tell me, who hasn't participated yet today, what is it going to be? Using the additive inverse. Yes, Sam. You are correct. 5x plus negative 12x. You got to simplify like terms. Negative 12 has a higher absolute value than 5, so we know our answer is going to be negative. It's going to be negative 7, what, donkeys? X. Negative 7x. Now we have this one, number 4, with that awesome dance move. Yes, I did have coffee. I have coffee every day. I only had 1 cup today because I need to go to the store on the way back. Like 12 ounces. Yeah. So, with that awesome dance move that you just saw, where one arm and one arm came together to create something else. I'm trying to think of how I can display. Ooh, I know how I can display it for the people listening at home. Okay, this is what people at home missed. It was. It was. I do this. We are still recording. So I had one arm like this. I had one arm. Let's do this. So plus 3QR, which equals Sydney 12QR. Beautiful. 12QR. And the reason why I'm doing variables in there is simply because that is your homework. Has a section on simplifying like terms. Okay? Has a section on simplifying like terms. So here's what you have to do now. You are going to do these 6 examples, and while you're doing that, I'm going to pass out the homework. So you must complete these 6 examples and the homework for tomorrow. Yes, ma'am. And I'll put the answers